Okay, so you've marked the homework, and before that you did your quiz, and now we're going to move on to the new material. So today's lesson, what we're learning this week is something called bioaccumulation. Okay, so bio as in biology, all right, so living things, and accumulation, so to accumulate means to get bigger. Okay, so you might want to, when you're older, accumulate money, which means to get more and more money. All right, or you might want to accumulate skills. And so what we're doing here is it's something obviously to do with getting more and more of something and living things. So the Earth's oceans contain huge quantities of microplastics. Now, microplastics are just very, very small bits of plastic, okay, that you can't even see. Tiny fragments of plastic as a result of human pollution. Okay, a small fish may consume a small quantity of microplastic without any effect to its health. Now that will happen because it's in the ocean and the fish is swimming around and it will just, as it's eating something, a bit of plastic will also go in. However, the fish will be unable to digest the plastic and it will remain inside the fish. Okay, so what we've got is, I'm going to draw the diagram and read at the same time. So you just need to watch for the moment. In a bit you can pause and you can copy the diagram, but you don't need to copy the diagram as I'm drawing it. You just need to listen. So imagine we've got a fish. Okay, right, some more of Mr. Dwyer's fantastic art skills coming out. All right, let's just draw 3 fish. Those are fish. Okay, now let's suppose that one fish eats 1 gram of microplastic. Okay, so in here this is one fish, and then I've got 1 bit of microplastic. So that red thing there, that's a bit of microplastic. Okay, and I'm going to say that it is 1 gram. All right. Now, a seal might eat 30 fish. All right. So what does that mean? Well, I've got 3 fish here, so each of these fish has got 1 gram of microplastic. Now, if I draw some more fish, okay, now they've all got 1 gram of microplastic inside them because they've all managed to consume 1 gram of microplastic. Okay, and if I go down and I say, look, I'm not going to draw out 30. Okay, so times 30 fish. All right, so in that 30 fish, how much microplastic is there altogether? Well, in all of the fish, there is 30 grams of microplastic. Okay, but because there's only 1 gram in each fish, they don't notice it, all right? It doesn't affect their health. But now comes the problem, because if I've got a seal, now I'm not very good at drawing seals. Don't really know what a seal looks like. Well, I know what it looks like, but I can't think of how to draw it. Oh dear. Oh, it's gone wrong. Oh dear. They've got. Ooh. Okay. All right. We'll have to label that. Okay, this is a seal. Okay, don't tell the art teachers. Okay. Right. So the seal is going to eat my 30 fish. Okay. Now, what that means is that inside the seal, I've got now 30 bits of microplastic. All right, so before it was only 1 gram in each fish. But because the seal eats 30 fish, now there's 30 grams inside the seal. Okay, so a seal might eat 30 fish. This means the seal has consumed 30 grams of plastic. All right, now a large polar bear might eat 5 seals. All right, now, I'm not going to draw out 4 more of those. It'd be a crime. Okay, so let's times that by 4. Now, if I have 4 seals, how much microplastic do I have? Well, each seal has got 30 grams. If I times that, times it by 5. Times that by 5, because there's 5 seals, there's this one and 4 more. 30 times 5 is 150 grams of microplastic. Okay, and if we have a bear, oh no, I'm very good at drawing bears, don't need to worry as much as with the seal. Okay, there we go. There we go. Polar bear. Perfect. Okay, don't need to label that one. All right. So that is going to eat my 5 seals. All right, which means that now in here, oh, that looks a bit gruesome, doesn't it? Let's not worry too much. Now we've got 150 grams of microplastic, which is quite a lot. Okay, so each fish only had 1, but each seal eats 30 fish, and each bear eats 5 seals. So what happens is, because this microplastic does not get digested, it stays inside the organism. So when you eat the organism, you also eat the microplastic. Okay, and we end up then with a lot of microplastic inside the organism. Okay, so what you can see is the amount goes from 1 to 30 to 150. It is accumulating. All right. Now, this example here, this is just an illustration to help you understand how it works. Right. This isn't necessarily exactly what happens, but there are some very, very well-known cases that I'll talk about in a minute. All right. So let's carry on. Because there usually are large numbers of organisms at the bottom of the food chain and small numbers at the top, materials and chemicals can accumulate in large numbers as they are passed up the food chain. So what we've done here is, that if I was to draw you don't know that yet. Sorry, no, we're going to do that later. All right, so we can come back to this when we do one of the later topics. But you can see that for each bear, okay, I've got 1 bear. All right, and then underneath that, I've got 5 seals, and underneath that I've got, well, if each seal eats 30 fish, I've got 150 fish. All right. Okay, so each bear, because it eats 5 seals, it's actually getting 150 fish. All right. Okay, so let's do a real example. So this is something that really happened. Okay, so we'll do the real example in a minute. What we're going to do first is we're going to think about how we can write this down, okay? Because obviously, you can't write this, let's say in an exam or something. All right, actually you can pause the video now if you want to make a copy of that diagram, okay? But now we're going to go on and write out what it would look like. So, we're going to answer 2 questions, all right? We're going to answer these 2 questions at the bottom here, this one and this one. But before we do that, we're going to model how you should answer the question using the example that I just went through. So, the question is, how can large quantities of microplastics accumulate in polar bears? Include a food chain in your answer. Now, what I've got is a poor answer and an excellent answer. So if I was to ask you to just write out your answer, you might write, an excellent answer, you might write a poor answer, you might write an answer in between, but I'm going to show you, we're going to go through and annotate them and see what the difference between them is. So, include a food chain in your answer. They've both got food chains, fantastic. And they've both got the food chains in the right order. Fish, seal, polar bear, fish, seal, polar bear. However, the arrows in here point from the seal to the fish. Here they point from the fish to the seal, which is correct. Which one is it? Yeah, this one. Whoops. This one's correct. This one is not correct. Now, why is that? Because remember, the arrow must show the direction of the transfer of energy. Okay, and also, therefore, it points from the organism that's eaten to the organism that eats it. Okay, now, let's have a look at this poor answer. So, the fish eat lots of plastic. Okay, so I don't like the use of this lots of, all right? It's very vague, okay? What would be better is if, you were to be specific, all right? But we'll come back to that. Now, 1 seal eats a lot of fish. Again, a lot. What do you actually mean? You need to be very specific about what you're talking about. So it will also eat a lot of plastic. Okay, that's the general idea. They've got the right idea. And then one polar bear eats a lot of seals, so it will eat even more plastic. All right, so again, this use of a lot of. All right, now they've got the right idea. So the fish eats plastic, the seal eats a lot of fish, so it eats a lot of plastic. The polar bear eats a lot of seals, so it will eat even more plastic. But it's not clear in this answer how this happens. So you say here, or I say here, one polar bear eats a lot of seals, so it would eat even more plastic. Well, how has that happened? Why does that mean? Why does eating lots of seals mean you get more plastic? All right, so it's not very clear. So let's have a look at this excellent answer. Instead of the fish eats lots of plastic, we have one fish will consume. All right, so we've already, we're now using more scientific vocabulary, a small quantity of microplastic. All right, so actually, yes, sorry, I forgot to mention that over here, the fish doesn't eat a lot of plastic. Okay, if it ate a lot of plastic, it would die. The idea is that the fish only eats a very, very small amount, 1 gram, and then that builds up inside the organisms. This person has also used microplastic, which is the correct, because in the question we were asked about microplastics, we weren't asked about plastic. Okay, and they've said that this may not affect its health. Okay, which is correct. All right, so very good. Now, a seal will eat a large number of fish, including all of the plastic inside them. So that is the key piece of information that this response was missing. That it didn't say how eating lots of fish meant that it would also eat lots of plastic. But now I know that the plastic is inside the fish. So if I eat the fish, I'm also going to eat the plastic inside them. This means that the small amount of plastic in many individual fish is now inside only one seal. Okay, so very good. They've managed to communicate that idea of, here, all the plastic in the individual fish is now inside one seal. Okay, and they've done that by talking about this many individual fish, only one seal. All right, good. And finally, a polar bear will consume a number of seals. Now, in this answer, we don't know the exact numbers. So if we did, we could sort of give approximate values. But let's not worry about it. A polar bear will consume a number of seals. If the polar bear eats 5 seals, then all of the plastic in each seal is inside just one polar bear. So it's the same thing here repeated. A large amount of plastic has accumulated inside the polar bear, and this may affect its health. So again, back to the question, we're asked about accumulation. So to use the word accumulate in your answer is a very good idea. Okay, so you might want to pause the video now and read through each answer a couple of times so you really have a good understanding of the difference between them. Okay, because now, for homework, you need to answer these 2 questions. Now, these are real life situations. Okay, so these are things that actually happened. All right. So DDT is an insecticide that was once used to kill insects. So the important thing that you need to know for this is that bioaccumulation usually happens for chemicals. Okay, now I know that I've done this one for plastics here, which is, it's an actual material, but I use that because it's easier for you to imagine it, that there's this physical bit of plastic, but generally it will happen with chemicals that can't be digested. So DDT is an insecticide, which was once used to kill insects. That's what an insecticide is. All right. If you think of other words like that, something like homicide, all right, is to kill a human. All right, so that's where that word comes from, homicide. You can think of regicide. You might have learned about in history. Regicide, so is to kill the regent, the king, or the queen. Okay, and insecticide is something that kills insects. Right, now, it's no longer used, as it killed many fish-eating birds. It's interesting. Why would something that kills insects kill fish-eating birds? Well, the fish fed on plankton, which absorbed the insecticide from rivers. Draw a food chain to show this and explain how the insecticide killed the birds, but not the fish. Okay, so your food chain is going to be plankton at the start. Right, that's your producer. That will be eaten by fish, and then the fish will be eaten by the fish-eating birds. Okay, so that's all your food chain needs to be, just plankton, fish, fish-eating birds. And then you need to show how DDT accumulates in that food chain. All right, and it's important to remember that it will only kill the animal once it's in a large enough quantity. All right, so it won't necessarily kill the fish, but it might kill the birds that eat them. And the final question. Mercury is a harmful metal. It can be absorbed by plankton, which is eaten by small fish such as herring. These small fish might be eaten by larger fish such as swordfish. By drawing a food chain, explain how mercury may accumulate in the body of a person who enjoys eating swordfish. All right, so you can imagine now you're going to have, there's going to be four things in this food chain. It's going to be plankton, herring, swordfish, and people. Right? And so this is something that we need to actually be careful about. All right, so this does actually happen, and it can potentially be dangerous. So you need to do answers to those two questions in your book, take a photograph of those, upload them to Firefly, and I'll take a look at them. Otherwise, I'll see you all next week.